Hello everyone, welcome to AU 2020 virtual event, first of its kind. Today's talk is on publishing multiple drawings into single PDF using forged design automation. The title explains about itself and it also tells us what we'll be discussing in the next few slides. Madhukar, simplicity is the soul of efficiency is the norm which I believe, and we'll also t- try to develop application which is simple and it efficiency. Design automation is all about efficiency. So I've been working with Autodesk for the last 8 years. I have joined in 2013, and I help third-party developers building applications on top of AutoCAD and force design automation. Design automation at its core, it's a simple drawing processing service. So this guy, you need to make the data available in the cloud or in behind the servers to us. Our services needs to be access to those data. Our services can communicate over HTTP. That's only protocol our services will be able to communicate. So you need to make sure the data is accessible. If the data is behind the protection, you need to share the authorization or the permissions to us so that our service can get access to those files. Once the data is available, you need to send those links. We will download the links and we'll process against the which activity which you have referred, and we will also use the plugin the referred in the activity. The plugin uses the app bundle structure, which is on the similar lines of what plugins you develop on desktop applications like AutoCAD or Revit, Inventor, etc. It also has the same bundling mechanism, that is package contents XML and contents. The same bundle structure is used for loading a third-party custom plugins. Once the process has been done, the results are shared, sent back with the same link which you have given to us, and the data is discarded. We do not store the data. This is a workflow diagram. It is important to understand uh, before designing the Forge application. Uh, the first thing is design automation provides with you a set of predefined activities. You need to check whether our workflow can be fulfilled with the already provided predefined activities. If not, the second thing, whether my workflow can be fulfilled with using simple AutoCAD commands. If not, then you think that your workflow can be only fulfilled with creating a custom plugin. Then you need to create an app bundle. App bundle needs to be uploaded to our design automation service, and you need to get those app bundle ID and you need to refer it in your activity. Now you got the bundle ID. The next thing is engine. You need to pick which engine you would like to use. AutoCAD comes with four variants. The current release plus previous three releases. The current release is AutoCAD 2021. The previous are 2019, 2018. So you need to refer the engine ID, and now we need to draft the parameters. If you look at in the example, there are input and output. So you once you confirm that what are the inputs you need for design automation service to function on your plugin. So for example, if your application is to process and populate the drawing with the block table attributes, then you may require a JSON file which will have all the inputs that required to populate a block table attributes. In that sense, you need to give that a local name for the JSON file, and you can name that as a parameters.json or attributes.json. So this, after downloading that JSON file, that will be renamed to the whatever the local name you have given in the parameters. But the parameter name input should be in sync with the arguments name. This is very important. The next activity, after defining the specification, you will post it to the design automation service. You will get an activity ID. you need to refer the activity in the work item. The creating or updating the activity is only one time job. Once the activity is finalized, the work item is the thing which is keeps changing for each drawing. So the inputs changes. When the inputs changes, obviously the output's going to changes. The relationship between the work item and the parameters is that same as the function and function definition. The input and output are kind of a function signature. So you need to respect the function signature. The call to the function keeps changing, but the definition going to remain the same in the module. So now we will create a simple .NET console application that will convert a drawing file into a PDF file. This drawing file is taken from the local disk and uploaded to object storage services and use that URL to the dozen automation and get the PDF. So we will see that in the action. If we go back, we have two. I also created two batch files. So uh, these are the packages that already added to the project. You can just click on install batch so that it will add the packages. And also I have this environment batch file where I have created my client ID and credentials. So to PDF. Let's open this. So once you create the new fresh project, .NET Core Console application, you'll be creating this project. So now we will we'll create a configuration config equal to new configuration builder. So to this we will add forge alternative and we will build it. This is important to get to load our forge dependencies in the runtime like environment variables. Next, we will use the config in, we will try to create the design automation API client. So for that, we need to create a service collection and add the design automation DI resource. The SDK comes with many DI helper extensions which will help us to participate our application with dependence injection. And next, populate with the service and build it. Then next, try to get the required service. So design automation client. Okay. Now API is got. Now we will get, we'll call the activity await API get activity async. So we will be calling this AutoCAD plot to PDF prod. If you notice the AutoCAD, it is in the form of owner, period, activity name, plus, and alias. So this is the uh, so let's add here config. Okay, now we will print out this console, right? And we will just format JSON convert serialize activity. And we will keep the indented. So let's run this. We will see. We will try with debugging. Put a breakpoint here. Now let's just run. This is how can debug this. So make sure the config has the environment variables. Yes, it has the environment variables. Okay. No, just call. So we got the activity. So let's stop. Now what we'll do is uh, we will s- we will use the spinner just to give the user a feedback when we run an async await APIs, which takes little time. So we can write fetching and so patterns. We use this something called bouncing ball. So here and we'll call this as a adjacent text. So let's call this and bring it down here, this guy. Okay. So we will use text. Okay, JSON text. So and this bouncing ball is an animated Unicode. For that we need to make our. We don't need this anymore. Console dot encoding output encoding equal to encoding UTF. So for the classic reasons, our console is an ANSI. We were making this as a Unicode. This looks fine. Just run this .NET build. Okay, let's delete .NET build. Okay, .NET run. You can see this one. So once it's complete, you'll get a tick mark, a nice visual feedback. And if you look, please notice that in the parameters there is a host drawing and result, and we will be using the same names for even in the work item. So the other application which I would like to show is the DWs to PDF, which is already created. Just I will quickly walk through it. So Um, let me go. I have used the same code here, but I extended here. So this is where it happens. There are three things. First, the setup the owner. It will check if our Forge application has any nickname. If not, it will create. And the next, we will prepare the storage URLs. And the input drawing is uploaded into the OSS bucket and we get those URLs and passed in the work item. So if you notice, if you come here, if you notice there is a host drawing and the result. Sorry, if you come here, I have used the same argument. I have used the same naming, what that is available in that's available in that's available here, host and result. So it takes one download URL and uploads output URL. The same thing, host drawing, local name and result. So this is the reason I wanted to get the specification of the activity using a design automation. Once I know the activity specification, I can draft my work item accordingly. Okay, we will go back to the PPT and you can see the demo here. So same thing, now we are setting the owner, ensuring the bucket exists, and we're uploading the input file and getting the signed URL. Yeah, the PDF has generated. So far, we have learned how to consume design automation services in ASP.NET Core, and we also learned how to use a predefined activity by converting a single drawing into the PDF. And now the next slide we'll discuss little complex where we'll be not using the predefined activities, but we'll create one of our own, and we'll also create a custom command which will allow us to create an app bundle and which we need to upload it to design automation service. So this is a design. So there are a bunch of drawings as a zip package located in Forge data management. We'll download it, we'll use a command to process it, and we'll send a PDF back to the OSS storage. So this is a design plan for our application. This is the web production app, and I have a console app. The first thing, you need to create a Forge app, get those client ID and client secret. And in the console application, I always use console application, and I do not create any web production app directly. This console application, I will treat this console application as a test bed. The first thing, I'll create AutoCAD plugin and I will test against AC Core console. If the results are satisfactory, I will send the app bundle to my design automation client. This client will upload the bundle, it creates an activity, and it starts creating the poll item. If if the results are not satisfactory, I have to change my code. It's need not that whatever works in AC Core console may not work in design automation sometimes because of incorrect configuration in the local names, or the passing the URL. So, or maybe you need to do some other work that requires in AutoCAD plugin. So um, when the changes are required, come back to the AutoCAD plugin. I'll rewrite my code. Then I will just trigger my this client application where our bundles get updated, activity get updated, and the polling gets against and the work item gets again started. So I will keep testing until I get the result satisfactory. then I'll note then I'll note down this activity. So I need not worry about again. In the production app, I only have the two endpoints. A start work item which will run this activity ID and will which also calls this callback URL from the start in the start work item. So when the design automation completes its job, this callback gets triggered. From the callback, I will call I will send messages to the browser client using SignalR. So this is the plan, and in app bundle code, we will be creating a DSD file on the fly. DSD is the text configuration file, uh, and an activity. So in our activity, there are three parameters: input file, zip, and result. And in the command, we will collect the drawings that has been provided by the input zip. We'll prepare a DSD file populating with the collection of drawings, and we will execute that DSD file using publish API. Uh, Once the activity is prepared, we'll call the work item. So we will require one template drawing that I'm downloading from the Autodesk servers, and this download URL is from OSS. And I also prepared a signed URL to to enable the design automation to publish the drawing into that upload URL. Put the PDF into upload URL. So it's important to understand the relation between activity and work item. The argument name in the work item should be in sync with the activities, and if you are using any local names in the activity, that should be synced with the bundle code. Now we will see the code now. This solution has three projects: client, bundle code, and web. Bundle is a plugin code. Let's see the plugin code. So this has one uh, first thing we will collect the drawings from the zip file and we will send it to the batch application, batch publish. This the important piece is here. While generating the DSD on the fly, the DSD gets generated with prompt for DF name by default, so we need to change it to false. And we also need to insert the init layouts to true so that the layout, we need not worry if the drawings layouts are not initialized. This enables, this will force the layouts to be reinitialized. Okay, and when coming back to the web code, so I have three endpoints. One is upload. When user selects and uploads the zip file, this endpoint gets called, and this gets processed and upload the files to the backend OSS in the backend. And when user clicks the process work button, this gets called. Here we will call the activity, and and in the work item we also send the callback URL. This callback URL gets triggered by the design automation service on completing the job. Once this gets called, we will send the status to our browser client using SignalR. So this, let's go back to the PPT. So this demo application uses these technologies: PDFJS, OSS, PDFJS for rendering the PDF file, OSS for storing the drawings, core as my server, SignalR for broadcasting, and Azure for hosting the web service. So this is the demo I have hosted on Azure websites. It's uploading the input. Now the work item is initiated. It has generated an ID. So you get the information. At the same time, the files are rendered here in the UI. So you can switch between the pages. Almost 18 pages has been generated. The drawing contains around like 14 to 15 drawings. So we can also download the result PDF. So this one. So next, thank you. And the source code of complete project and my work is published at this location, batch publish. You'll find the entire work which I have discussed in this talk. And further reading, please go through the design automation documentation and modify models. And another core for .NET Core. This link talks about the signal UR. Thank you.